Hello, today I would like to show you how to use the Admet Predictor by Simulation Plus. So we will use the version 10.4. So the newer version can offer us to do the simulation for IR oral and IV bolus. So we will start with designing our drug. So we can manually draw by click the insert clipboard structure and Metcam designer. So in here we can design our drug based on the structure that we want. So basically you can play around with the atom given based on your desired drug. If you want to insert the alcohol or oxygen, you can click the O beside here, or if you want any solid charges, you can click it here, and you can also erase the unwanted atom. So as for now, I will like to design an anti-cancer drug with some phosphorus extension. So after we satisfied with our structure, either we can save, or for me basically I will click under the structure section and click transfer and close, so I can transfer my structure into my Admet Predictor, and then I name the structure. For example, for here I just write unknown and click OK. So we can have our first structure. So if we already have the simplified molecular input line entry specification or smiles, we can insert the smiles here. So here I already paste the smile up there, and then I name paclitaxel, then click OK. And for the third drug is docetaxel, and also I click OK. So basically we already have 3 drugs for us to compare. And then we will start with Admet properties. Calculate the Admet properties by clicking the Admet properties, and then do it for the all spreadsheet rows. And from here, if you have a specific pH or any specific pKa, you can set it here, and then click OK, and then click calculate. It will automatically calculate for the properties, Admet properties for your drug. So here you can see the physiochemical properties for all of our drugs. So in here we will want to focus on the Admet risk and the Admet code. So we will given like a sort of a score for Admet risk. For example, for paclitaxel is 10.5 and docetaxel is 8.3. So the higher the number means that the higher the risk of the drug with the potential Admet problems. You can read it here, and then you can also read the legend by pointing the cursor at the name of the section. So same goes to the other physiochemical properties for the drug. There are also some absorption, for example permeability to the cornea, permeability to skin, and ECS, absorption risk, absorption code you will like to observe and discover. So for the next is the transporter. So this is more to the distribution of the drug. So if we want to take a look at the metabolism, it also shows us the enzyme involved in the metabolism of the drug. And last but not least, we take a look at the toxicity section. So this is also very important. So it will give the insight about our drug behavior on human and rats and mouse, and it also gives us the information either our drug will be sensitive to our skin or sensitive to our respiratory system. And for the summary of the toxicity, we can focus on the toxicity risk and the toxicity code. So next we focus on the simulation part, the PBPK simulation. So we click the CP time curve. So here we can choose the species, so I choose human, and then the dosage form I use is IR tablet, and the dose might be 100 mg. and then we clearance towards liver, and this is the result. From here we can see the graph, the area under the curve, the clearance, the T-half, and the VD basically. But for these three drugs, the curve is not very readable, so we need to compare between two drugs first before we compare with the unknown, because the unknown have a better absorption rather than the paclitaxel and docetaxel. So from here we only highlight the paclitaxel and docetaxel and rerun the system again, so we can get a better readable graph. So from here we can also make it a log graph to understand the better absorption, and we can export the data into a file, onto the text file. But for me, I'm only focused on the picture of the graph and save it as a PNG files, and click save. And next we're gonna look at the structure sensitivity activity. So based on our Admet data, so we can see from the structure itself how it can contribute into the specific Admet. For example, for HERG filter, so the red indicates it not favorable, but the green indicates it's favorable for HERG filter. And same goes to the other parameters, such as here is CYP to C9, so some can be metabolized at the particular structure. And if you're really interested in to take a look in depth about the descriptor sensitivity analysis, so we can click the DSA here, and then we can select either gradient bar or sensitivity line. So here I click the sensitivity line for the mouse TD50. So from here you can see the relationship between mouse TD50 and the nitrogen bond and O bond. So we can utilize the descriptor analysis to redesign our drug back. And now we can also predict the dose estimation for all of our drugs. So if we can know the target concentration, for example for this IV bolus in human, I target for maybe around 1 nanogram per ml based on the concentration average. And to get the optimum dose in human, so I run the process, and okay, so from here we can get the optimum dose. So from here, this dose can help in obtain our desired concentration, which is 1 nanogram per ml. So we can utilize this program also to predict the pKa microstate for our drug. So click under the tools, and from here we can see the unknown is sensitive towards two different pKa compared to paclitaxel, only 1 pKa, and docetaxel is only 1 pKa. So we can check the solubility profile for our unknown, which is true, two different pH will have a better solubility, and for the paclitaxel also can verify in higher pH have a better solubility, and for the docetaxel also in docetaxel. So we can verify our data by looking at the log D profile. So from here we can see the log D of the unknown as compared to the other log D. and we can save the data, save the picture actually into the PNG files. So for next, we can predict the metabolite if it is metabolized for the specific CYP. So we select all spreadsheet rows, or you can select only one molecule. So from here I select all the CYP enzyme and just click calculate, and it will open a new Admet Predictor software. So from here it will display for you the metabolized structure starting with the M2 until the final M. So you have the insight what's the intermediates after the metabolism happen inside your body, depends on the enzyme. And that's it. That's the beginner tutorial for how to use the Admet Predictor software by Simulation Plus. So if you have any question, don't hesitate to ask me, and inshallah I will answer all your questions. And thank you and have a nice day.